Hey there, Python pioneers, and welcome to another video. Thanks for joining me. So, in the last few lessons, we learned about expressions, assignment statements, basic data types, some functions that you can use. But based on what we've learned, you're only able to write a program that executes every line of code that you give it. And the power of programming comes from the ability to add something called flow control. So what that looks like is based on how an expression evaluates, you're able to skip blocks of code, repeatedly run blocks of code, or even only run certain blocks of code when an expression evaluates to a certain value. So that adds a ton of power to programming. And actually, ironically, um, a lot of what some non-tech inclined people might think is artificial intelligence or a highly intelligent machine turns out to just be a lot of flow control behind the scenes. So let's jump in and let's learn a little bit about flow control. Okay, so this is from chapter 2 of Automate the Boring Stuff. So at the end of this video, make sure before you go on and continue watching, you go and read chapter 2 from Automate the Boring Stuff. This diagram actually comes from the book, and it's a great illustration of what flow control looks like. So we have a start, the program starts, and then we have a question. Is raining? So is it raining? Yes or no? Let's keep track of this idea of yes or no, true or false. Let's say it is raining. If it's raining, execute this expression and check, do we have an umbrella? Yes or no? Again, yes or no. True or false? Let's say it's false. No, we don't have an umbrella. Wait a while. So instead of having a question, we have a statement that's executed. We're waiting a while. Then we come down, we have a question. Is it raining? So we evaluate this question and check this expression, is it raining? And if it is, then we go back and we wait a while and we do something. Let's say it's not raining anymore, then we can go outside and do that. So it seems very simple when you look at it in this way, and actually it's that simple in code as well. You just have to learn how to write the Python code to say this. But flow control is happening right here. So in order to actually measure, I guess you could say, for flow control, we need this yes or no value, right? We need to be able to check for if something is true or false. In all of these cases, it's always yes or no. We're not having any other value except yes or no, true or false. And that brings us to the next data type that we need to learn about, Boolean values. All right, I'm in the Mu editor and we're going to take a look at Boolean variables. So first off, we talked about true and false, right? So we have true and false. Notice that when you write out a Boolean value, you must capitalize the T and the F. If you write out lowercase versions, Python doesn't know what you're talking about. So make sure you capitalize if you're going to write out a Boolean value. This is a value just like this is also a value, but this is not a Boolean value. Even if I capitalize, it's a string, right? Because it's wrapped in quotes. That's a value. 201.1. We got floating points. We got an integer. We got a string. These are boolean values. So true or false, yes or no. We can store these in a variable, and there's a special way that we want to name that variable. You could just name your variable x equals true, but that's not useful. So if you give your variable if you follow a special naming convention when you name your variable, it's a little bit more helpful. And in programming, what we like to do is use the word is. So is creative. So I know that because it starts with is, this is a Boolean variable. That's helpful because when you get further down in your code and you can't see where this variable was defined, you know just from looking at the name that this is supposed to be a Boolean variable. And now is creative, or if it's true or false, it depends on how you set it. But if you're going to, it just depends on how you want your flow to go, really. I mean, you could say is not creative, and that's also helpful as long as it starts with is. That's what really helps you be able to know it's a Boolean variable. Now, that is particularly useful when we start getting into flow control. You don't always need a Boolean variable to do flow control, but sometimes you want to have one and you keep track of some true or false condition. So it's useful to learn about Booleans now, especially because now we're going to look at relational operators and how they produce a Boolean value. Okay, so we are outside of Mu now, and we are just taking a look at a nice picture from chapter 2 of Automate the Boring Stuff. And we're talking about relational operators. Relational operators are very useful, and they allow you to compare two values to evaluate to a Boolean value. So true or false. Just like we saw is raining and it was true, or it was yes or no. In the same way, when you see that diamond shape in a flowchart and it's asking a question, you use these relational operators to ask a question. So when we look at equal to, and this is an important one to point out. Remember when we were talking before about the assignment statement, it's a single equal sign, right? And I told you to remember it's not for equality. The single equal sign is an assignment statement. It does not test equality. So the double equals is testing for equality. It's called the equality operator or the equal to operator. Whichever one you want to call it is fine. And an easy way to remember that is when we look at the other relational operators that have equal sign in them, they all have two operators. So if you struggle to remember if it's equals or equals for testing for equality, just remember that if I want to test for with a relational operator, if I want to ask a question, is something equal, I have to have two to use an equal. Because when we look at does not equal or not equal to, we have an exclamation point and an equal. So not, think of when you see the exclamation point, imagine your Python interpreter yelling not. So not equal to. That's one way that I try to remember it when I was first learning. Not. That's what the exclamation point means, is not equal to. And then you have less than, which is normal, greater than, less than, equal to, or greater than, equal to. Those are all standard, just like in mathematics, as you've seen before. So with these relational operators, we're able to test these two values, right? So is 42 equal to 50? that's not true, right? It's not equal to 50. So that would evaluate to false. So let's jump over to mu and I'll show you what this looks like. Okay, we are in the mu editor and let's type out some code and see what relational operators look like in Python when we actually write them out and how they evaluate to Boolean values. So if we write out, let's create a variable called my test. My test equals, and we're going to assign a value to it. Let's use relational operators to assign a value, just for testing out what is actually happening behind the scenes. We're going to use these relational operators in a different way very soon. So if we say my test equals, let's say 1 plus 1 and is greater than 3. Now we know that 1 plus 1 is not greater than 3, right? So the variable is just here to store the value that this expression is going to evaluate to. We could just do it like this for the sake of showing you, but when I run this, I don't get to see what happened. So it did something, but we don't know what it did. So let's go ahead and, like I said, create a variable and call it my test, and we're going to assign whatever this does. We know that 1 plus 1 equals 2. So when this expression evaluates, 1 plus 1 will be changed to 2. And then now we have 2 is greater than 3. That is false, right? So this will evaluate to a single value, false, right? And I'll show you that because if we write this out again, and then let's print out whatever is in my test. Let's print that out and see what it does. It prints out false. So the expression evaluated, and now we have a Boolean value of false. So that's pretty straightforward. I could show you greater than or less than, but those all really work the same as exactly how you would expect. But does not equal, I mean, we could look at that. So same thing, 1 plus 1 does not equal 3, right? So if I run that, we're going to get true because 1 plus 1 does not equal 3. Now if I change this to 1 plus 2, I get false because 1 plus 2 equals 3, and 3 does not equal 3 is false. So I know, like, when you start getting into this like double negative stuff, it can get kind of confusing, but just try to work through it step by step. 3 does not equal 3. Now think to yourself, if you say it out loud, is that a true statement or a false statement? 3 does not equal 3. 1 plus 1 does not equal 2. If someone told you that, you'd be like, you're crazy. 1 plus 1 equals 2. So if someone says 1 plus 2 does not equal 3, you tell them they're wrong. They're false. So that's computer science, and in coding we say false. So just that'll take some getting used to when you start getting into some of the double negative kinds of things, like thinking about like, if something is not this, then it's true, and you're like, oh, okay. But in any case, so greater than, equal to, all those, you can look at them. This would be true, right? Because 3 is greater than or equal to 3. All right. Now enough of that. Let's jump in and actually see, how do we use these relational operators to control what what code executes.